Welcome back to Azure AI Essentials. Today, we're going to look at how you can add optical character recognition and AI-powered search capabilities to your applications. We're going to focus on document processing, a popular scenario, but the concepts you'll learn here will apply to other scenarios as well. Organizations today are processing more documents than ever before. Think about paperwork needed to buy a car, filling out tax forms, or documenting work you've completed. Processing a large amount of documents is a reality for every organization and industry. Now think about how much time it takes to process all those forms and the variety of forms that need processing. Internal forms may have to be handled differently than customer forms, and if they're filled out by hand, it may be hard to read all the different types of handwriting. Processing all these documents manually is time-consuming, inefficient, and leaves a lot of room for human error. Organizations across the globe are integrating AI solutions into their workflows to help automate document processing. Let's get started by walking through a typical document processing scenario. This diagram represents the main components for an automated document processing solution built on Azure AI. Over the next few minutes, I'll walk you through these components: OCR, Form Recognizer, and Cognitive Search. We'll start with optical character recognition, or OCR. Handwritten text can be difficult to parse through. With Azure Cognitive Services, you can leverage OCR capabilities that can extract both printed and handwritten text from images and documents. You can add OCR capabilities to your app using a portal experience or with computer vision APIs or SDKs for C#, Java, JavaScript, or Python. The Computer Vision Read API extracts printed text in several languages and handwritten text in English, along with digits, currency symbols, and more. It's optimized for text-heavy images and multi-page PDFs with mixed languages, and even supports detecting printed and handwritten text in the same image or document. The first step is to use the API's read call, which takes images and documents as input and supports a variety of file formats. For large, multi-page documents, you can provide a specific page number or page range as an input parameter to extract text just from those pages. Here, we have a variety of document types. As the Read API parses through each of these documents, it uses OCR to detect the text and read what's in them. This also works for documents that have a mix of languages on the page. You can see that the computer vision model detects each language and is not confused by the images on the pages. In each of these samples, the API is called and extracts text from the image or PDF input and returns a JSON response. For each line of extracted text, the JSON will output the line of text along with bounding box coordinates and a confidence score. As you just saw, OCR can be really helpful to reduce the time it takes to process images and documents. The next Azure AI service that will help you streamline document processing is Form Recognizer. Form Recognizer can accurately extract text, key value pairs, and tables from documents, so you can quickly turn forms into usable data with no machine learning expertise required. Similar to OCR, Form Recognizer is built on top of the Computer Vision Read API. While OCR can detect text lines and words, Form Recognizer can understand document structures, fields, and values. Form Recognizer is comprised of three parts: the Layout API, pre-built models, and custom models. Let's take a brief look at each one of these. We'll start with the Layout API, which can extract text, tables, and checkboxes from documents. Given a form, Form Recognizer detects each cell in a table, as well as numerical values, currency symbols, and characters. In the JSON output, the rows and columns are indexed, along with their bounding boxes and elements. Next, we have pre-built models. Form Recognizer currently supports two pre-built models: sales receipts and business cards. The business card pre-built model extracts information like name, title, address, and company. The receipt model is optimized for common English sales receipt formats, like those used by most restaurants, gas stations, and retail stores. The model extracts key information, such as transaction time and date, merchant information, and tax amount, and returns it in a JSON file. Finally, we have custom form recognizer models. You can train custom models with your data to tailor the model to forms specific to your business. For example, this W-2 form does not follow a standard table of rows and columns, but has more of a key value layout with different boxes and fields. So it's best to use a custom model here rather than the layout API. Training form recognizer custom models does not require manual data labeling, and you can get started with as few as 5 sample input forms. If your form images are of lower quality, we recommend using a larger data set, such as 10 to 15 images, to train your model. This way, your model has a better chance of extracting information. Azure also offers the Form Recognizer labeling tool to select fields from your form and train your model in a supervised approach. This is especially useful if Form Recognizer is not picking up all the content you're targeting. First, you'll create a new model, then choose a custom image or form to analyze. You can train custom models with labeled or unlabeled data. Form Recognizer uses unsupervised learning to understand the layout and relationships between fields and entries in your forms. When you submit your input forms, the algorithm clusters the forms by type, discovers what keys and tables are present, and associates values to keys and entries to tables. You can see here that this custom model detected the important information in the form, the checkboxes, severity, and more. Now let's look at the JSON, which return the read results, page results, and document results. Right away, you can see which model was used, in this case, a Unix one, and even the submitter's name and bounding box. Whether you're processing documents, receipts, business cards, or forms unique to your organization, Form Recognizer can help extract valuable information from them. The final step of automated document processing is searching your data. Azure Cognitive Search is the only cloud search service with built-in AI capabilities that enrich all types of information to easily identify and explore relevant content at scale. Cognitive search can be broken down into 3 steps: ingesting your data, enriching your data, and exploring your data. We'll start with ingestion, the first step to indexing your unstructured data. You can create an Azure Cognitive Search resource in the Azure portal and connect to a data source from there, or you can do this programmatically. You can ingest data from Azure or third-party sources across a range of formats, including images, audio files, PDF, CSV, and more. Now that you've ingested your data, the next step is enriching your data. Data enrichment is the process of enhancing your understanding of your data with cognitive skills, for example, image classification or language detection. Enriching your data allows you to produce new fields in your search index that are not available natively in the source. You can leverage pre-built AI models with Azure Cognitive Services or build something custom. One thing to remember here is to make sure you create your Cognitive Services resource in the same region as your Cognitive Search resource. Applying AI capabilities such as OCR, translation, key phrase extraction, and entity detection is as simple as checking a box in the Cognitive Search portal. Next, we're going to customize our search index by defining the index properties. The Cognitive Search resource automatically identifies metadata related to the files we chose earlier, but you can customize by making each of these fields retrievable, filterable, sortable, and searchable. So now you've ingested your data, added cognitive skills, and created an indexer. But what does this mean for our document processing scenario? So far, we've been setting up our search criteria so we can easily surface valuable information rather than going through it manually. You can select how often your data is searched and indexed. If you're ingesting documents every few minutes, like at a doctor's office when patients are checking in, you might want to index your data hourly. If you're expecting field technicians to send in daily reports, you can index your data daily. Finally, you're ready to explore your data. You can integrate custom models or classifiers that can be built with the language or framework of your choice, and explore insights with pre-configured search or through analytics tools and business applications. In our example here, we can search for the name of Microsoft CEO, Satya, and as you can see, we get a letter that he wrote. All the other fields we'd previously defined, people, organizations, locations, these are also extracted from these documents. Let's try one more. Let's search bot. Now this text is surfaced in Spanish, but because we chose for our indexer to translate it for us, we can scroll down and see the same information extracted in English. Cognitive search works with several file formats and built-in indexers and supports over 50 languages. You can query your data through APIs or the portal to quickly transform raw, unstructured information into searchable content to make your document processing workflow more efficient. This is just one example of how organizations can use Azure AI to modernize their business. There are many ways you could extend this solution by integrating with other Azure AI services. For example, you could use Personalizer to provide personalized content or document recommendations, or Metrics Advisor to detect odd behavior in your company's data. And you can apply OCR, Form Recognizer, and cognitive search to help solve a wide range of business challenges beyond document processing. Thanks for tuning in to Azure AI Essentials.